posterity. Okay, so just to review, and because there is no existing video on this, and I'll put this up. Combinations, it's an arrangement of objects where the order does not matter. Okay, think about being dealt a hand of cards. You don't care what order the cards come in. You're going to arrange them. The formula for arranging n objects, you're choosing r objects from a set of n, so it's n choose r, or ncr, is n factorial over n minus r factorial, which you'll notice right now, that's the permutation formula, and then we take out all of the orders, so we divide by r factorial. Here's 4 choose 3, here it is written in this notation, and then simplified, and here's 49 choose 6, which is the way of getting how many possible combinations are there, combinations, right, or an arrangement where the order doesn't matter, of 6 numbers from a set of 49 for 649, 13,903,816. Schoolhouse Student Council with 22 members, 14 females and 8 males. We want to form a fundraising subcommittee that has 7 members. If there's no restrictions, it's just 22 choose 7. You plug that in your calculator. If the subcommittee is all female, there are 14 females, I'm going to choose 7. There are 8 males, I'm going to choose 0. You don't have to put this in, okay? But I like to put it there so that my top numbers add to 22, my bottom numbers add to 7. That's the way. If we subtracted this from this, we would get the number of committees that have at least 1 male, right? 1 or 2 or 3 or 4 or 5 or 6 or 7. Okay. Now, what if we want exactly 3 males? So we said there are 8 males. I want to choose 3 of them. There are 14. Now, what operation do we add these 2 together, or what do we do with them? Multiply, right? Because the way I want you to think about it is, I am choosing 3 males from a group of 8, and is what operation? Yeah, and I'm choosing 4 females from a group of 14, so it's multiply. Okay, so you could do 8C3 times 14C4, okay, which numbers I don't have handy. But wait, so it's 8 times 7 times 6, it's like 56, I think, for this one. And there's no way I'm doing that one in my head. So what's 14 what is 8 choose 3? Is it 56?
Yeah.
Okay, what's 14 choose 4?
1001.
1001? What's 56 times 1001? 56,000, 056. I suppose that kind of makes sense, right? With 56,000 and then 56. Makes perfect sense. Okay, so exactly 3 males there are, 56,056. And the last question is at least 2 males. At least 2 males. Okay, when you get this, they're not even paying attention. I did this for posterity, but at least 2 males. So when you get these types of questions, I want you to sit down and think, what does at least 2 males mean? How many males could there be? So now, this is you thinking. So there are how many?
2.
Yeah, so there could be 2 males, or 3 males, or 4, or 5, or 6, or 7. What does or do? You add. Okay, but wait a sec. That means I have to do 2 males and 5 females, right? 2 males and 5 females, plus 3 males and 4, plus, okay, that's too much work. So, if I have at least 2 males, what don't I have? So you don't have 1 male or what? So you don't have 0 males or 1 male. Right? Now, that's pretty easy to do, right? 0 males, 8 choose 0, 14 choose 7, 1 male, right? Like this is, let's work out 2 things. Oh, but wait, we've got to subtract that from all the possible committees, right? This is, let's work out 2, 3, 4, 5, 6, 7. Let's work out 6 things and add them all together. Yeah, okay. Now, if I have a choice, here's what we're going to do. So we're going to take all subcommittees, minus those consisting of exactly 0 males plus exactly 1 male. Okay? So if we take all the committees and subtract off the ways, the sum of no males or one male, what are we left with? At least two. Right? There's going to be 2 or 3 or 4 or 5 or 6 or 7, but we don't have to work out 6 separate things. So all subcommittees is 22 choose 7 minus, okay, how do you get 0 males? Okay, so here we could do 8 choose 0 minus, okay, so 8 choose 0, that's the 0 males, and then 22 choose, oh sorry, this is 22 choose 7, this one. All subcommittees is 22 choose 7. I was getting ahead of myself. So the all subcommittees, already did that. It's 22, I'm going to choose, I don't care who's who. All males, or sorry, 0 males, 8 choose 0, 22 choose 7. 1 male. What do we do for 1 male? So 8 choose 1 and, sorry, it's 14 females. Wow, that's up. You couldn't have said something, like you knew, right? Like, this is not going well, but I'm not going to step in and rescue him. Like, just you flounder. Go ahead, I like watching that. Fine, I'm just going to fill in the rest. I almost put fraction bar. Do not put a fraction bar in there, right? It's tempting because this is like a fraction, but it isn't, right? Because a lot of times we'll write a fraction in a set of parentheses. Oh, it's 14 over 6. No, it's 14 choose 6. Okay, is this correct? Given your track record, I sort of doubt it, but I think that it sort of makes sense, right? So there are 22 people on the committee, choose 7. Okay, we already have that number, right? What is it? It's 170544. Right? We worked this out already. Minus. Okay, exactly 0. We actually already worked that one out already too, didn't we? So that was 3432. Going the wrong way. Okay, so this is 3432, and what's this? Sorry, how much? 8 choose 1. 8 choose 1, by the way, is 8. But you do, so you're going to go 8 math PRB C1 times 14 math PRB C6. Enter. PRB is over to the probability menu, right? Okay, so what's 8 choose 1 times 14 choose 6? 24,024. Okay, so to that we're going to add 3432, and we're going to subtract that number from 170544, giving us what?
143088.
143088. Okay, and if nobody wants to contradict that, then that's what we're going with. In a small sense, it doesn't really matter because you're not exactly going to sit down and memorize these numbers, right? I mean, given a similar question on the quiz, you're going to be working it out yourself. Now, your alternative, if you really like doing work, is to sit there and go 8 choose 2 times 14 choose 5 plus 8 choose 3.
That's the wrong answer.
That's the wrong answer. Okay, what's the right answer?
146,520.
146,520, perhaps. Who agrees with that? I don't.
I got the same answer.
Oh my God, let me get another calculator. No, okay. Okay, I'm going to do this in one fell swoop. So I'm going to enter 22 math PRB C7 minus bracket 8 choose 0, that's 8 times 14 math choose 7 plus oh sorry, that's 1.
Your previous answer was right. Yeah.
1. Well, hang on. Plus 8 times math 6. 143088. Definitely. Now, keep in mind, on a test, maybe this is listed as the possible answer, right? Like in other words, they give it to you in, what's the fancy word? Combinatorics notation, right? Or you could see this. which I don't think you would because I don't know why anybody would do it this way, but right? So you could just, it's 2 males, or 3 males, or 4 males, 5 or 6, or 7 males, right? Just or you're going to add them up. So it's 2 males and 5 females multiplied. Why do you need 1 female? Does it say at least 1 female? What was the thing? At least 2 males. So how many males is that? 2, or 3, or 4, or 5, or 6, or 7. It was only a 7-member subcommittee, right? If it was a 9-member subcommittee, we would need at least 1 female, right? Because there's only 8 males. So, no, it ends there.
It's so tempting to put the fraction bars in.
I know it is, right? Yeah. It's very tempting to put fraction bars in. On the diploma, it doesn't matter. Go ahead, write all the fraction bars you want because nobody's looking at that, right? But they're not there. Okay? If I say determine and you write fraction bars, you're going to lose maybe nothing. I mean, it's right. It's sort of like, yeah, whatever. Okay. Card games, right? Card games. So, as a lead-in to probability, the study of probability resulted as a result of what? What was the impetus for studying probability? Gambling. Right? So if you were going to invent a game and there was going to be gambling involved, then you needed to know, what am I going to win or not, right? And so every casino in the world is set up so that they're going to win eventually, right? You play the game long enough, you're going to lose money. Otherwise, there would be no casinos in business. So it's all based on probability. So if you are going to choose to gamble, you need to study probability, right? You need to decide, well, which game am I going to, no matter what game I play, in the long run, I'm going to lose. But where am I going to lose the least? Like, in which game? So that's the whole study of probability. And if we're going to study probability, then the first thing to know is we have to know how to count. We have to know how many ways things happen, right? So if we're talking card games, and let's talk about a standard deck of 52 cards. So standard deck of 52 cards. And let's deal with a 5-card hand. So any card game where you're going to get dealt 5 cards, right? The most famous of which would be what? Poker. Okay. So in a poker game, not talking Texas Hold'em, a whole different story, right? But again, you have to know the math. You know, if you're going to play Texas Hold'em, those guys know the math, right? They can calculate in their heads, I have this is what I know, these are my odds, right? Now, not as well as the people on TV, because the people on TV know everybody's cards, so they know for sure the odds. You playing, you would just know your odds. All I know is this is my chance of winning. Okay, and then you base your decisions on that. Okay, so let's say we're dealing a 5-card hand, and we want to know how many ways can you get all black cards? So the question is, how many black cards are there? 26. How many of them do I want? So that's going to be 26 choose 5. How many red cards are there? How many of them do I want? 0. You don't need to write that. You may not see that written. I like to because this says, look, I'm covering off all 52 cards. These are the black ones. These are the red ones. I need 5 black and 0 red. Okay. And 26 choose 5, I can do that for you, is 65,780. So, all diamonds. So how many ways can you get all diamonds? So 13 choose 5. because there are 13 diamonds, right? There are 13 of each suit. How many other cards are left? 39, just the other 3. And how many of them do we want? 0. You're not necessarily going to see this. Again, I like to write it in. 39 choose 0. Anything choose 0 is just equal to 1, right? It's just 1. It's like, don't choose any of them, right? Everybody's going to choose all diamonds. And what else have I chosen? You have chosen 0 clubs, 0 hearts, 0 spades, right? There's one way to do that. You don't choose any of them. So what's 13 choose 5? 9,200. 1,000. 1,287. I swear to you, just yell. 1, 2, 8, 7. Good. I told you. It's like, no Q-tip. C. 3 kings and 2 queens. What's and mean we're going to do? We're going to multiply. How many kings are there in a standard deck of cards? 4. 4. How many of them? How many of them do we want? How many queens are there in a standard deck? How many of them do we want? We could then go on and say there are 40. So we dealt with 8 cards, right? So you would take those. So you'd have your kings, your queens. Say there's 4 kings. I need 3 of them. There are 4 queens. I need 2 of them. There are 44 remaining cards, of which I need 0. So we could write, I'm not going to write it this time, but we could write 44 choose 0. Okay. And then my top numbers add to 52, my bottom numbers add to 5. 4 choose 3 is 4, and 4 choose 2 is 6. So there are 24 ways that you could have, what's 3 kings and 2 queens called?
Full house.
Full house. Now we know who watches late night sport and then it turns over into poker. It's a full house. What are the other? So in poker, what are the possible hands, starting at the lowest, going to the highest? So high card, pair, 2 pair, 3 of a kind, straight, a flush, full house, straight flush. No, 4 of a kind, and then a straight flush. So what's all diamonds called? So if you have all of the same suit, what's that called? No. Okay, it's called a flush. Is this the number of diamond flushes there are? No, because some of those are straight flushes. So a straight flush, oh, I forgot straight flush. No, that's straight flush. So a straight flush is all the same suit, and the cards are in numerical order. So like 4, 5, 6, 7, 8. That would be a straight flush. All of diamond or all of hearts and so on. Right? So when we deal with working out probabilities in poker, we have to realize, oh, this is not all of the flushes, right? This includes the straight flushes. We would have to get rid of those if we're counting, right? So this is counting methods, right? So we're just learning how to count. If you're going to delve more deeply into the game, then you have to look at, well, so did that really count what I think it counted? 2 pairs. D, 2 pairs. So how many ways, if you are dealt a 5-card hand, how many ways are there of getting 2 pairs? So what does 2 pairs mean? Give me an example of 2 pairs. 2 4s and 2 5s, right? Pair of 4s, pair of 5s. What's the 3rd card? Okay, but what isn't it? It can't be a 4 or a 5, right? Okay, so if we're going to get 2 pairs, we first need to choose which cards, right? Like, is it kings and queens? Is it aces and 2s? Right? So if you think about it, it could be, well, an ace and a 2, an ace and a 3, ace 4, ace 5, ace 6, ace 7, ace 9. Okay, so you say, well, wait, how many ranks are there? From ace to king, there's 13 ranks, right? So 2 pairs. So we're going to go 13, choose 2. There are 13 ranks, and I need to choose 2 of those, right? So it could be ace and 2, ace and 3, ace and 4, and so on. 13 choose 2 is 78. So there's 78 possible ways to choose the 2 ranks, right? Ace 2, ace 3, ace 4, ace 5, ace 6, ace 7. And again, we don't care about order, right? You get 2 aces and 2 6s, the same as getting 2 6s, 2 aces. Right? Order doesn't matter. So you could count those all up. Actually, by hand, you could count them up relatively quickly. Just sit there, get the settings. Anyways, once we've chosen the two pairs, then we say, okay, so I've chosen, let's say, kings and aces, right? Because that's like the best two pairs. So aces again. How many aces are there?
4.
And how many of them do we need?
2.
2. How many kings are there? 4. How many of them do we need? Okay, we got to get a 5-card hand. How many cards are left that aren't these? So these guys have to add up to 52, right? So we're actually doing kind of something like this. How many cards do we need out of these 44 non-kings, non-aces? 1, because I got to fill in a 5-card hand, right? So this is kind of the separate calculation, right? 4 choose 2, 4 choose 2, 44 choose 1. Work that up. But then this is the number of ways that can happen. Okay? Because it can't be one of these guys. Okay? So you think about it and you say, I have 52 cards, right? So I'm going to take my 4 aces, make a pile here. Take my 4 kings, make a pile here. And here's the rest of the cards, which is 44 of them, right? So I have 52 cards. From this pile of 4, I want to choose 2. That can be done 6 ways. No, that comes out. Okay? That's in there to say, the 4 choose 2, 4 choose 2, 44 choose 1 just says, how many ways can you get 2 pairs? The 13 choose 2 says, how many different 2 pairs are there?
Oh, okay.
Right?
Yeah.
Okay, so we just multiply that all out and we get some number. The number we get doesn't matter, right? I mean, it's a calculator exercise at this point, which you should not mess up. So your answer could come out in this form, right? Your answer could be given in combinatorics notation. Your answer could be a number. So you have to be willing to say, so what you want to do in these cases, look at the answer. Oh, they're all numbers. Okay, so I'm going to take this and I'm going to work it out, right? I'm going to get a number. Look at the answer. Oh, wait, it's written in factorials. Oh, okay, well, that's probably like fundamental counting principle or permutations, right? Look at the answer. And maybe the answer is written as some of them are NCR and some of them are NPR, right? And so you got to ask yourselves, oh, okay, wait. Does order matter? If order matters, you cross off the NPRs, right? You don't care about those. If order doesn't matter, you cross off the, if order does matter, you cross off the NCR, because those are ordered. And if order doesn't matter, you cross off the NPR, right? So you're down to 2, right? I mean, so if you're guessing, you can at least say, wait, I know that order doesn't matter. Order doesn't matter in a combination. So I can cross off the permutations, just leave the 2 with combinations. Okay, and then you can figure it out from there. All right, last. Is this the last? Second last example. Who cares? No, seriously, it's a calculator exercise. Work it out, get a number. Yay. I don't know what it was. I never worked it out. Here's my key from last year. It's not worked out. Okay. But seriously, it's just go 13 choose 1, or sorry, 13 choose 2 times 4 choose 2 times 4 choose 2 times 44 choose 1. Okay. The number, because like I said, maybe the answer is just in combinatorics notation. If it's an actual for real number, then you're going to punch that in and work it out. Right? I'm not comfortable. Math should always end in a number. I don't feel comfortable you just leaving this undone.
Well, we both did it. We got 2 completely different numbers.
Well, figure out who messed up. Did anybody else work it out? Did anybody work, other than these 2, did anybody work it out? Odds are not good. How many triangles can we draw? All right, hang on here. We'll pause. Can we draw using the vertices of an octagon? Okay, so what's an octagon? 8 sides. What's a famous example of an octagon? The stop sign, right? Unless you're into mixed martial arts, and then it's the octagon. So a stop sign is an example of an octagon. It has 8 sides, right? 1, 2, 3, 4, 5, 6, 7, 8. These are the vertices, right? Vertices just where the lines join. How many vertices? There are 8 vertices. I want to draw a triangle. How many vertices do I need to draw a triangle? 3. So, what's the answer to how many triangles can we draw using the vertices of an octagon? 8. Choose 3. We have 8 vertices from which to choose, and we need 3 of them to make a triangle, right? Any 3 will do. Okay? Doesn't matter which 3. It could be 2 beside each other. It could be 3 beside each other because you can draw a triangle, right? There, triangle. It could be 3 totally different ones. This one, and then this one, and then this one, and I can make a triangle. So how many triangles can I make? 56. Does it matter what order I join them in, right? Like, is this different from this? No, it makes the same triangle, right? That's why it's 8. Choose 3. The order in which you draw doesn't matter. Okay? You just have to draw a triangle. Okay, last question. At a minor hockey tournament, all of the players meet on the ice at the end to shake hands. If there were 300 handshakes, how many players were there? If there were 300 handshakes, how many players? Were there? Okay, so at a minor hockey tournament, either little kids or guys that work underground, people that work underground. All of the players, probably the first if not the last, meet on the ice at the end to shake hands. Doesn't really matter, it's just people. If there were 300 handshakes, how many players were there?
Do the players shake hands?
Yes. Everybody's shaking hands with everybody. I know, they're more likely to pat them on the back or the bum if they're teammates, but you know, they don't want to get as familiar with non-teammates. But they're just going to shake hands. So yes, everybody is shaking hands with everybody else. Okay, how are we going to do this? Bless you. Okay, so if I shake hands with Ali, is that the same as him shaking hands with me? Okay, so we are not going to worry about order. If we worried about order, then me shaking hands with him would be 1, right? Be like, you know, Steve, then Ali, and then Ali, then Steve. So it's not a permutation, right? Order doesn't matter. So it's a combination. You're close. It's more. We know there were 300 choose handshakes. So how many players are there? Like, we don't know, right? So let's say there are n players. Then what are you going to do with those n players? You're going to pair them up, right? Each pair of them. So how do I pair people up? If there are n, what do I want to choose? How many people does it take to shake hands? 2. So it's going to be n choose 2 is equal to 300, right? So I'm going to n choose 2, so I'm going to pair everybody up, and they're going to shake hands, and in total there are 300 handshakes. Okay, so you could solve this algebraically, and on a diploma what they could do is give you the steps, and then it's the old where is the mistake, right, or something along those lines. Okay, so we will do this algebraically, and then we'll do it the way that we would do it if it were asked on the for real thing, right, which is use your calculators. Okay, so n choose 2 is n factorial over n minus 2 factorial, 2 factorial, and that's equal to 300. Okay, so that's the setup. How much is 2 factorial? Just 2. So let's get rid of that 2 factorial. What are we going to do with this, which is just a 2? We're going to multiply both sides by 2, right? So I'm going to get n factorial over n minus 2 factorial is equal to 600, right? So you just say 2 factorial is just 2, 2 times 2. Multiply both sides by 2, that gets rid of this, and this becomes 600. How do we simplify this? It goes back a long time in the unit, but our units are really short, so it doesn't go back that. We start expanding n factorial, right? So n times what? N minus 1 times what? Times what? Nothing. You stop there, right? What do we do when we stop? We just put down a factorial symbol. Why did we stop there? Because I've got that here. I can cross it out. They're both 1. That's equal to 600. So I've got n times n minus 1 is 600. So n squared minus n is 600. So n squared minus n minus 600 is equal to 0. It has to factor, right? Because n has to be a natural number, right? We can't have 6 root 2 hockey players, right? Because n is the number of hockey players. We can't have 6 root 2. It's got to be a number. So this works out to n minus 25 times n plus 24. So this means that n equals 25 or n equals negative 24. So what are you going to say about that? It can't be negative 24, right? You can't have negative 24 hockey players. So what are there? 25 hockey players. Okay, so there's your answer. Now, how are you going to do this on a test? You are going to say, I'm not going to solve that. You're going to say, I wish my calculator would work. Okay, and then your calculator actually comes to life and you say, okay, so here's what you're going to do. What? Pay attention. Pay attention. Let me find this. You go to y equals and you say x, math, over to PRB, choose 2. So we're doing that, I'm going to say x choose 2, right? Because I can't say n choose 2, I don't have an n. And then you're going to say, I'm not going to graph that, that would be silly. I'm going to go look in the table. And what am I looking for? Well, this is n choose 2. I want it to be 300. So I'm just going to scroll down until I see 300. And unsurprisingly, it's going to be at 25, right? I mean, this should, wow, it's 25. You know, we already solved it algebraically. Okay? So you don't, if they give you an answer, you don't have to solve it algebraically, right? So how, on a diploma, how do we force an algebraic solution? We could say an expression on the way to solving this is, and give you, let's say this, so we could say A, n factorial over n minus 2 factorial is equal to 600. B, n factorial over n minus 2 factorial 2 factorial is equal to 600. C, n minus 2 factorial 2 factorial. Now I can't say equals 300 because then I have 2 correct answers, right? So, you know, can't do that. 150. That's starting to get silly now, right? But in other words, you know, you could get stuff in a form that you're going to get. Okay. Could also go like n squared minus n minus 600 equals 0. N squared minus n is negative 600. Like stuff like that. So in other words, anytime you're working something out algebraically and you want to say, how could they ask me that on a diploma? It basically comes down to showing you a solution with an error in it and asking you in which step does the first error occur, not the first arrow. In which step does the first error occur? Which of the following is a step that would be in the algebraic solution to this? I haven't written a lot of those. This time I write some more. Next time I go up to write, I think I'll do that, right? Like which of the following could be, and I'd probably say could be a step in the solution, right? Now only one of them is going to be correct, right? But it basically forces you to say, I need to show how to do this algebraically, and so you basically do an algebraic solution and then look for one of your answers. You look for one of the answers as part of your solution. Okay, so that's another way that that kind of thing can be done. Okay, and if it's just multiple choice or numeric response, you can just plug in x, choose 2, and just look for the 300, right? You know what's going to happen, and by looking at the numbers, you can see it's going to happen pretty quick. Like if I just scroll down, I'm not going to have to go down to like, all right, I got to go to like 300, right? You couldn't possibly go that far anyways, right? Because 300 choose 2 would be way more than 300. Okay.